Hey guys, how you doing? So it's been a little bit, and times are a bit crazy right now. So we are, as with the whole school, converting to a full online program. This is going to take some learning. We're gonna, on both ends, there's gonna be some problems. We're gonna try to stay connected as best we can and provide you guys with the best educational experience we can, considering what's going on in the world. Um, I'll be honest. I think a lot of this is going to fall on you guys in terms of putting the time in, allocating the time to really dive in and look at this and put your minds to it. And I have no doubt that you guys are going to be able to kill it. And of course, we're going to be here. I'm going to be here to support you guys. Shoot me emails. We can talk in the discussion boards. I'm going to be posting shortly just kind of our schedule for the remainder of the year. How this is going to go down. Basically, we're going to go in weekly sprints, and we're going to have discussions, assignments, and lectures. So what I want to do today is do one of the lectures. So just to kind of quickly review where we left off, we should all now be running with our DVD screensaver, right? So we have this classic DVD screensaver working now, and the DVD logo is bouncing around the screen. If anyone has not gotten here yet, which it looks like I think all of you have, definitely reach out to me. I'll get back to you with a video lesson. We can also connect in real time if you want via Zoom or something like that. So we should be here. Now, really the big takeaway for this project isn't the fact that we're animating an image around the screen. The big takeaway is that we're using conditional statements. And the core of this lesson is that we are using conditional statements to control the flow of our program. So we literally created these walls in our program. It appears like the walls are the window, like the size of the window, but in reality, we've defined them ourselves using these conditional statements, and the bounds just happens to be the width of the screen and the height of the screen. So the key takeaway, again, is the idea of these conditional statements. And if we look in our code here and we dive into our DVD logo, all of this program really boils down to these walls, right? So this is the key takeaway is understanding what's inside of these conditional statements and the logic that powers them, right? So we're making sure that the X position is not greater than or equal to the window width. And if it is, we're going to go ahead and turn the direction around for the right wall, and etc. We go down to all the different walls. So I want to take a step back from this, and I want to talk about a new concept, a new set of tools that allows us to control the flow of our program. Conditional statements you can think of very much like a kind of choose your own adventure type of control or of tool, right? Think of it like if you're writing a book and you could say, hey, go to page 10 if you want to do this, or go to page 20 if you want to do this. Conditional statements let you do that type of branching in your program. So you can have these different paths in your programs. You can have path A, path B, or path C, and depending on where the program goes, you can define the logic for how it goes down those paths. Extremely powerful stuff. You can control a lot of different things in a program by just using conditional statements. One other thing, though, that is really important when we're writing programs is to be able to do things over and over and over and over and over again. So if we want to say add a number over and over again, or maybe draw a circle over and over again, instead of writing a line of code over and over again, we can actually write what's called a loop. So what I want to do is I want to introduce you guys to this idea of a loop. And there's a bunch of different ways for us to define loops. There's a couple of different types of loops that we're going to introduce to you. But what I want to do first is let's go ahead and create a new sketch. So we're going to back up a little bit. We're going to get back on the horse here, and we are going to write a new sketch. So just a quick review. I'm going to right click on the sketches folder. I'm going to go to new file, and let's call this program loopy, because it kind of feels a little loopy right now with everything going on, and concentrating on things like this, it seems very hard when the world is a mess. So let's get a little loopy together. What do you say? So let's go ahead and call this file loopy.js. Awesome. So we're going to go ahead and click create. Now we have a loopy.js. Now, I'm not in the classroom to say it, but I'm going to say it anyway. What are the two functions we need to define in order to get a sketch going? I'll give you a second. I hope you guessed it. The first one is our setup function. And then the second one is our draw function. Excellent. So I'm going to go ahead and define our setup function. And we'll go ahead and define our draw function. Cool. Now, what is the first thing that we want to put in the setup? Right now, we're going to paint on a canvas just like a painter. But do we have a canvas yet? We don't, right? There's no canvas. There's nothing. There is just two functions, and that's it. So let's go ahead and create a canvas. And we'll create a canvas with the screen width and the screen height. And you know what? Let me just go back and reference this because is it window? Oh, we're using window. I've been bouncing around between another processing program which uses screen. So we want to use window here, not screen. So window width and window height. Okay, awesome. So now we have a canvas. Why don't we go ahead and just put a little bit of, just paint it all white. So I'm going to say background white. That'll make it white. And let's stop right there. Now we have a basic sketch set up with a canvas and a white background. What's the next thing we have to do? If we want to execute this program, it's a JavaScript program, and we want to now execute it. What do we need to do? Okay, I hope you guessed it. We want to go to the index.html and link that bad boy up. So right now, it's linked to the DVD logo, right? We have this sketch here, linked to DVD logo. Let's go ahead and link this bad boy up to our loopy.js and save that, right? Remember, Control S or Windows S is to save. Okay, so now that is connected, and we should now be able to go and run our program, and we shouldn't see anything. It should be a white background. But now to prove that this works, let's go back here and let's just make this black. Let's go back to our program here and refresh it. And boom, it's black. So now we know that our sketch is actually running. Cool. So we'll keep the background black for now so we can see it actually paint something. Now, we've done this a couple of times already within our draw function, right? This draw function, how fast is this draw function? How many times a second is this draw function being called? This is getting called 30 times per second, right? So if we go ahead and we say, let's draw a ellipse at, I always spell, am I spelling ellipse right? Ellipse 20, 20, 20, right? And whoops, we don't want that up. Let's go here and refresh that. And now we have a circle at 20, 20, 20, right? Now, if we wanted to see this actually run all across the screen, we have the X, Y, and radius parameters, right? So why don't we make random window width and random window height. Right? So now when we have syntax like this, it can get real frustrating real quick, right? And we're all experiencing that, where we have all these open parentheses and closed parentheses, and you have to keep track of where the heck is this all laid out. And it gets really annoying because if you do this, the whole thing won't work. And then you want to rip your hair out, and it's annoying. So really pay attention to the opening and closing. The editor does do a little bit of a job to highlight that. But if we go ahead and save that, now if we refresh this, we should see that this is looping 30 times per second. So right off the bat, without introducing any new keyword in the programming language, we have already been using loops throughout this class. You just didn't realize it yet. So the draw function itself is being called inside of a loop. And that loop is calling this function 30 times a second. So the draw function already is within inside a loop, which is kind of cool. So if you think of it as just kind of constantly being called. But what if we wanted to control our own loop? We want to control our own destiny with this loop, right? So we want to control the flow of the program ourselves. Now, we can control the draw function and how it's called using the frame rate function, right? So I think we could just go here, right, in our setup, which is what we've done in the past, and say, frame rate 20, and we can set our frame rate to be slower, right? And now this will run a little slower. We can set it much slower to really get the effect. And you can see here that, okay, now we're really going slow. So we're controlling this loop by calling other functions, and what those other functions are doing is just modifying the actual loop that's calling this draw function. But let's get a little more powerful. Let's get the power into our own hands. Let's go ahead and make our own loop. So we're actually not going to use the draw function here. I'm going to take the draw function out. We're not going to loop inside the draw function. Let's concentrate. I'm going to take the frame rate out. Let's concentrate on just the setup. And I'm going to actually take the draw function out altogether because we don't want to draw anything in the loop. This should still work, right? Because we could just set up a canvas and not draw on it. So boom, we have a black canvas and there's nothing happening here, right? And there is a P5JS function that allows us to declare that there is no loop to happen, right? And I think it's just called no loop, right? So no loop is going to allow us to say, hey, only call the draw function once, right? So we can do that as well. We could say no loop, and then the draw function will be called once, or we can just write our code directly in the setup. So right now, let's do that. So let's keep it as simple as we can, and we'll draw our code in the setup function. So now, say for example, we wanted to draw 100 ellipses randomly to the screen, right? That seems like it should be pretty simple. I'm going to go ahead and do that. I'm actually going to go ahead and grab this here so I don't have to retype it. So I'm just going to cut this and delete this again, go here. And we're smart programmers. We could do this. So let's go. Let's go ahead and draw 100 ellipses to the screen. All right, we're just going to go ahead and just paste this in here 100 times, right? And I don't want it to do that. Let's go ahead and all right, guys. So you could probably go take a nap if you want. Come back in a little bit, and I'll be done with this once I'm on line 100. Now, say I'll just draw 20 for now, so this doesn't take too long. Now, this right here is something that even outside of creative coding, we're hit with all the time in the professional world, is a lot of people today do their work like this, where they accept the fact that I just have to paste this in here 100 times, and now when I run the program, I'm going to get 100 circles randomly drawn to the screen. You'll satisfy exactly what I said. You'll be able to get that program done. It's going to be tedious, and it's going to take a lot of time to do, but you can do it that way. And even outside of programming, a lot of people do things in extremely inefficient ways. And when you're in the workplace and you see people doing work like this, and you understand how software works, that's where you can become such a powerful asset for your team, because you can come in there and say, hey, I can make this a lot better. We can make this a lot more efficient if we just maybe used a loop or automated this in some way. In a lot of cases, loops allow us to automate tedious tasks because it allows us to do the same thing over and over again by just defining that thing once. So as you can see here, I can go ahead and paste this in here 100 times, and it will draw an ellipse to a random location of the screen 100 times. But there's a better way. We can actually do this with 3 lines of code. So let's go ahead and see what that looks like. I'm going to go ahead and delete all but one of these ellipse calls. Now, I'm going to make sure my indentation is right. And now I'm going to wrap this in what's called the first type of loop that I'm going to introduce is a for loop. Okay, so a for loop uses the for keyword. Right, you'll see that it turns a little orangey because that's symbolizing that it's a keyword in the programming language. So a for loop, we're going to open our parentheses, and now the for loop, just like function calls, this isn't technically a function call, but it kind of behaves like one. It's almost a mix between a function call, and a conditional statement. So the for loop takes as its first parameter we call the initialization variable, an initializer. So we can call this variable anything, right? Remember, we can call our variables anything we want. I'm going to call this variable something very simple because it's just a looping variable. So I'm going to call it I. And I'm going to say I equals 0 initially. So this is where we're starting from. We're starting from I equals 0. And then we're going to put a semicolon in here and a space. So this is the first section of our loop. That is the initialization. We're initializing our loop. We're starting at the ground. We're starting at 0. Now we need to declare where we want to end. Where do we want this loop to end? So if we're starting at 0 and we want to draw 100 circles, if I went from 0 to 100, how many circles would I have? Think about that for a second. 0 to 100. I would have 101 circles, right? Because 0 is where we're starting, not from 1. And this is a kind of a very popular gotcha for folks that are new to programming. A lot of times we index things starting at 0. And 0 to 100 would be 101 times. So what we could do is we could say, we're going to loop while I is less than 100. So really, this loop is going to go from 0 all the way up to 99, which would be 100. I know that may sound confusing, but play around with it a little bit. You could play around with these numbers to see how it changes. We could, if we wanted to go up to 100, say less than or equal to 100, and that would do it 101 times. So we're just going to keep it at less than. So you can see here, we're combining a couple of the key concepts that we've learned so far. We're combining a variable with a logic statement like we saw in the conditionals inside of what looks like a function call. So we're kind of like jamming together a couple of concepts. Now there's one last piece here. We need to tell the loop exactly how it should increment I while it's looping. So to do that, we need one last section of the loop. So we're going to say I plus plus. And that's just basically saying that every iteration of the loop, I should increment by 1. Which makes sense because we want to go from 0 to 1 to 2 to 3 to 4 to 5 all the way up to 99. Well, we'll stop. Now, if we wanted to go up by 2, we could say I plus equal 2, and that would go 0, 2, 4, 6, 8, and etc. But we don't want to do that. That would mean the loop would loop half the amount of time. I'm going to go just plus plus. Now, just like a function and just like a conditional statement, we're going to open that curly. And let's go ahead here. I'm going to close the curly. Now, inside of these curly brackets, there is nothing right now. So we need to put this ellipse inside of the loop. And now, by looking at this like this loop, this block of code that's inside of the loop, and we can have a lot of lines of code here. It doesn't have to just be one line of code, but this line of code will execute how many times? It'll execute 100 times, right? So now if we save this and we go ahead to our sketch and refresh this, boom, there's 100 circles on the screen. And they're all randomly placed. And we did it with 3 lines of code instead of 100 lines of code. So that's the power of a loop. And there are a bunch of different types of loops that we can do. The for loop is usually the one that we introduce with when we learn programming. But there are things like the while loop and the do while loop. One aspect of, and I don't think I'm going to go directly into the do while or while loops just yet. Let's focus on the for loop for now and the 3 aspects of the for loop. So again, there's the initialization variable. In this case, we're starting at 0. Then there is the conditional, which basically says how long the loop should loop for. And then there's the incrementation, how we should increment this looping variable. And then within the actual curly brackets is where we can do all of our code. So what I want you guys to do is, for the assignment, create a program that does the for loop in the draw function in a no loop situation. So you want to use this no loop here to basically just use the draw function and then put the loop inside of the draw function to draw a square randomly to the screen 500 times. All right? So I'm going to go ahead and post this lecture in the discussion. Please post any questions that you may have to the discussion. I'll get back to each one of you individually. And I'll most likely be posting another video later this week, if not next week. And there's a lot of stuff I want to get into. I know we're quite behind. So I may be, I might not be going into the do while loop. Maybe I'll just post some content on what those are, but basically the same concept, being able to loop and do the same thing over and over again. In the next sections, what I'd like to get into is more complicated data structures, so we can start to develop more interesting programs. We do have, the next project is kind of a soundboard application. So I don't know how many of you guys play instruments, but what I'd like to do is develop a soundboard that allows us to kind of play an instrument with our keyboard. And in that, we're going to be exploring user input and sounds. So that should be fun. But in order to get there, we definitely need to know a little bit about looping and more of the complex data structures like arrays and objects. So that's really what I want to get into next, is arrays and objects. But before we do that, we definitely want to finish off our control section with the for loop. All right, guys, any questions, let me know. Thanks.